Hey, I don't have an obsession with natural log NE, but Dr. Bolnami is actually an engineer, and they always use natural log NE for everything, and that's what we do. In fact, I was showing my son how to do a problem yesterday, and I just used natural logs, and he goes, can't you use log base 10? Yes, you can, but out of habit, I just use natural logs. So this one, if you just do some front-end work first, you realize natural log and E are inverses of each other. They cancel each other out. I think I've shown you that before. So this is really 3, and this is really 3x. Again, it looks like it blotted something out there. That's really 3x. So this top that looks kind of scary is not really scary. It's 3 minus 3x. And you can do this by quotient rule, but you don't have to. If you do some front-end work, you realize that you have, hey guys, up with me today. 3 minus 3x, the 3's cancel out, and you're left with 1 minus x over x. That's really, if you go, I call this backward common denominators. I'm going to be using this a little bit more in the second half of class when we're using integration. Usually when you were little, you had to combine this and get a common denominator and go that way. Now split them up and go this way. Because 1 over x is really x to the minus 1, and I can power rule that thing. And that's why I'm doing it. Power rule is the easiest of all the rules. Do you agree? Easiest to apply. So that I'm setting myself up to use a power rule. So now I can take the derivative of this guy using the power rule. And then I think I left that off. So take the derivative of this using power rule. What do you get? X to the, that's it. Negative 1, x to the minus 2. And you're done. Then the second part is 0. Derivative of negative 1 is 0. I had this one. I was reluctant to answer this one, and I don't think I go all the way and answer this one. Because this is what we did over and over at the beginning of the semester, and I should have actually tossed that back up on a quiz so that it just reminded you it, but let's go back over it. In the cases that we went over at the beginning of the semester, the x1 was a number. And towards the end, I kind of like gave you, oh, now we're going to let x1 be x. And I didn't go over it too long because I knew the rules were coming next. But if I have something like this and I wanted to take the derivative, what the kids call the long way, and they are kids. They're kids. They've never worked outside of their home, and they're being paid by their parents to go to school, so they're kids. So x1 equals x. Wouldn't that be nice? Not working during college. Y1 is 3x squared minus 1. X2 is a. Y2, how do I find the Y2? I take the X2 and where do I get this from? You plug it back into the original formula, and then you calculate the slope. Y2 minus Y1 over X2 minus X1. 3a squared minus, you just take and put them up like one of those movies where they just take it with a finger, move it down. Take that with your finger, move it down. Take this with your finger, move it down. This. And if you don't put those parentheses up, you're dead. Because nothing will factor and you'll be stuck.
That's what we did in the beginning.
Right?
That's what we did in the beginning.
That's what we did in the beginning. And so then the next step is you always, no matter what you do at the next step, it's got to be some algebra involved. That was what all the algebra you learned was leading up to. Every class you had so far was leading up to calculus, so you can use it in these kind of problems. Right? So here, if you don't have those parentheses up, then those ones won't cancel. So that's why if you don't put those that's why I give you those problems all the time with the parentheses left off. Because if you don't have those parentheses up, it screws you up for the rest of the problem. So now those drop out, they're gone. And I'm going to let you factor this at your desk right now. Factor this, and something will cancel. If something doesn't cancel, if something doesn't go away in that reduction step, I think I called it step 3, then you know you made a mistake. Somewhere in the previous step you made a mistake. So try this out. See if you can get it to cancel and then let a slide to x and tell me what you get. tiny piece of chalk. Did you steal it? A little nub left. Where did you put it?
I left it like there.
Let's see it here. Oh, okay. Anybody think they got it? Now everybody's scared. Gene, you get it? There you go. If you think that I don't know your name, I know all of your names. So I'm going to call on you soon. Right. One more step, you know? Now you just let this slide. A goes to X. Do you see it? Okay. Alright, if you took the derivative, if you go back up here at the top, do you have any questions on this work? All questions directed at Gene from now on. Gene, raise your hand so they know who you are. Look back at the top. What if you took the derivative as the Georgia Tech kids call the short way? What would you get if you took the derivative? 6x. So part A was do it this way. Part B is why wouldn't you do it the other way just to check if your work is right? So I think the directions in the review sheet were do it this way or else, right? Like do it both ways. Make sure that it's right because you have a way to stop up and check. Is anything confusing up here that's been written on? Up here? So this is difference of squares. He factored out, he did two things in one step here. He did pulled out the 3 first, and then he has a difference of squares. This is a minus x times a plus x. And then you cancel. So at that step 3, if something doesn't reduce and cancel, something went wrong in step 2. Either a parenthesis was left off, most likely a parenthesis was left off. That's where you find something's wrong. Oh, this was, page is messed up. This is the previous page. I'm showing you that you can actually, I should have numbered the pages. Somebody said they were confused about these y equals x sine x and use the log method. I did not cover this. This is just beyond what you will need. If you're taking PChem, you will need this. But if all of you are not taking PChem, and maybe that's the reason you're a bio major, like you looked at the class and went, this major doesn't have PChem in it, I'm signing up for it. If that's the reason, you'll never see it again. But, here we go. Just to show you what it is, when you have a power with x here like this, it's not x squared, there's a variable up here, you use something called, you just rephrase it. So you just use an e and a natural log. This is the same thing, right? Because the e and the natural log cancel. So it looks like I've made it more complicated. But then I have this sine x comes to the front by the log laws, this power. And e is really, in coding, we actually have it written as a function. And the old scientific calculators that you probably don't use anymore, they don't have an e button, they have an exp button. You plug in things, so this is your inner. You have an inner and your outer, and it's a chain rule. So you have inner is sine natural log x, your outer is found by covering up the inner with your thumb. All the methods, the algorithm's all the same. You see that there's nothing different. It's just more complex looking. So derivative of the inner, well, I need product rule for that because the inner is a product. You were asking the question about this, whether this is a product. There's no inside of a function. I have one function times another function. And if I put a parenthesis here, the x is already the input of this function. So if I put a parenthesis there, it means that I'm multiplying this function times that function. So then I have first times the derivative of the second times the derivative of the first. Where did the cosine come from? Got to memorize it. It's up here. So I tell the Calc 1 students if they sometimes ask me, we have cheat sheets? Like, whatever I have up here, you've got to have up here too, because if I have it up here, it means that I used it. That means that, well, that's why I know it, because I can't remember anything. I can't remember anything. I don't even remember what's supposed to happen tomorrow. So everything has to be told to me. So if something's here, that's pretty scary. That means that it's stuck in there somehow. That means I use it. That means they have to use it. So that's why you need to memorize just those four. They have like a long list to memorize, so you have a shorter list than them. And then derivative of the outer is e to the x. You guys already told me that. And assemble. Derivative of the outer with the inner plugged in times the derivative of the inner. More complicated looking, but the steps are all the same. So you see this diversion, at least in the career of a person who's going into math, you see this division between your fellow classmates. Start. You know, like at some point you're all together on the same page, there's a group of you, and all of a sudden you're the only one standing. And the reason for that is, one of the reasons I think is lack of fear. So I would look at that and say, oh, I'm supposed to use chain rule. It looks ugly to most people, but to me it's like the same thing. Same procedure. So those scary looking functions do not scare me. And that's not nothing to do with smartness, it's bravery. It's courage. So be courageous. Look at it and don't go like that. Just look at it and just go, okay, this is just a chain rule. So what's the steps in chain rule? And just list it out. And all will be good. And then you might see yourself separating out from your colleagues and going and getting a PhD in math. No? I didn't have to take PChem. Okay, last one I'm going to show you. I'm actually going to have you do this in class. The way that Dr. Golnavi has written on there is using log transformations. You don't have to. You can use it's a bunch of chain rules, so it's a little messy. So write this problem down and we'll do it together in class. Obviously you're going to have to use the quotient rule, right? Has a top and a bottom. So list out the top and the bottom. The issue will come when you have to take the derivative of the top. It's messy. So again, be brave. Take it on.